Right? Look here, students. Now, today we are talking about the Fleming's left hand rule. Fleming's left hand rule, how it is, how it will work. Look here. Class 10 Magnetic Effects, video 4. Fleming's left hand rule. 3 fingers we need. Left hand, 3 fingers we need. One thumb and one showing finger and middle finger. 3 fingers help we need today. Look here. 3 fingers are there like this. Face to you, that is better to understand. When you are facing to you, then feel that is thumb is going up. Showing finger 90 degree maintaining to thumb and middle finger 90 degree maintaining to thumb and showing finger. Middle finger maintaining 90 degree to thumb and showing finger. Thumb maintaining 90 degree to showing finger and middle finger. Middle finger, showing finger maintaining 90 degree to thumb and middle finger. So here, what is Fleming's left hand rule? Look here. When current is passing, pointing to your side, when current is passing through middle finger, then what is showing finger, what is showing finger, what is thumb? Look there. Current passing through it, current passing through it, then motion is in thumb side and magnetic field is in showing finger side. Look here. Current face to us. Field, magnetic field is thumb side, motion is upside. What is that? Look here. Now I am telling you. Fleming's left hand rule. Stretch your 4 fingers, not 4 fingers. 4 finger and center finger and thumb. Here 3 fingers, one showing finger or 4 finger, center finger or middle finger and thumb. 3 fingers now we are using here. Very clear. Look here. What is that? Mutually mean perpendicular, not parallel, perpendicular to each other. Already I told you. Such that four finger points in the direction of, look here, 4 finger points in the direction of magnetic field. 4 fingers showing us magnetic field. And center finger indicates direction of current. Already I told you. Center finger indicates direction of current. Current is flowing. This is magnetic field. Magnetic field. And what is thumb? Look here. Where is that? Thumb giving us direction of force of motion. Force of motion. Magnetic field is other. Force is other. Force of motion upside. Which force, sir? That is important. Look here. Which force will come in machine? In machine. Look here. Force of motion. Remember, first of all, what they are showing. Once again, thumb is showing force of motion. Forefinger showing magnetic field. Center finger or middle finger showing flowing current direction. What is that? Electric motor. In this motor, when you are assuming, look here, commutators are there, brushes are there commonly, and after a year, this is copper wire. This is our device is this only, rotating device is this only. Name here A, B, C, D, whatever. When you are naming, look here, this is our device which is working. So look here, outside of this device, exactly we kept one permanent magnet. electric motor. It is a device which converts electric energy into mechanical energy. Water motor, having electric energy converting into mechanical energy to give us the water. To give us the water. What is that mechanical energy? Look here, principle. That is definition. Electric motor definition I told you. It is a device which converts electrical energy into mechanical energy. What is principle? When rectangular coil carrying current. When rectangular coil is carrying current, when current is flowing in this rectangular coil, then there is the current placed in magnetic field, it experiences the force. That coil is experiences, meaning is that magnetic force is working on the coil. Magnet force of permanent magnet. Permanent magnet having one force, that is called magnet force. That permanent magnet force, when working on the coil, ABCD coil, rectangular coil or copper coil. When working on the copper coil, then what it is doing? Look here, the force that rotates it. That ABCD coil is rotating itself. Why? That is important. When current is passing into the coil, and that current is experiencing the permanent magnet's force. The permanent magnet's force is working on the coil to rotate it. Coil is rotating when current is allowed into the coil. If current is not allowed into the coil, what should happen, sir? Coil will not rotate. When current is allowing into the coil, then the current allowed coil is experiencing. If current not there in the coil is not experiencing. Coil is not rotating. So here, when coil getting current in it, then it is experiencing the permanent magnet's force. If current not there, it is not experiencing. Because one magnet can oppose the magnetic objects. One magnet can attract the magnetic objects. Copper is not attracting, I am telling. When current allows, the allowed current is creating one magnet around of the coil. Allowed current is creating one magnetic field around of the coil. Remember. And what is that next? Look there. Sorry. What is that? ABCD. In horizontal plane such that magnetic force is parallel to plane as of coil. A to B in segment AB, current flows from A to B, applying Fleming's rule that it experiences force in upward direction CD. Next, in segment CD. So look here, I will explain to you. When current is entering into the coil is rotating. Actually, coil is jerking. Why jerking? Because allowed current is creating one magnetic field. Less amount of magnetic field is created with allowed current. That less amount of magnet is jerking because the high amount of magnet force already there. That high amount of magnet force is forcing less amount of magnet which is created with the current. Then that coil is rotating. After rotation, this is coil. After rotation, current is cut off because brushes connection is cut off with commutators. Commutators are a side. I will explain you when you will get. Commutators are a side. So here look. When current is not working, when current is there, look here my dear students. Power on. So here when coil is there, that coil ABCD, when AB comes up, CD goes down. AB comes up, CD goes down. When CD, look here, CD comes up, AB go down. Here this is coil. Coil is this ABCD. When AB goes lay down, then CDs are straight. Look here. Here magnet force is working on the coil. First of all, we need to jerk the coil. We need to jerk or we need to give a small motion in coil. So we can give the motion in coil with the help of allowed current. That allowed current can create magnetic field, I told you. Created magnetic field and permanent magnetic field, both are opposite. So permanent magnet, when allowed current is rotates, when allowed current is rotates once, then brushes and commutators are cut off their connection. Brushes connection can stop, brushes connections can cut off from the commutators while rotating the coil. Once when coil is rotating, then brushes connection can cut off with the commutators. Okay, brushes connection cut off, but the coil movement is gained some energy. Coil movement, which energy gained, that energy again opposite. I mean that energy cannot stops the coil. When again it will comes down, current can allow again to jerk the coil. When again it comes down, then current again allowed. Then the allowed current can jerk the coil. So this will repeats again and again. Once it comes vertical, that device can lose or that device not having current. But already I told you one word, look here. CD and force acts downwards. Here the two forces of ABCD and CD, AB and CD, two forces equal and opposite forms couple and rotates the coil in clockwise direction. AB force and CD force are equal and opposite. That forces are rotates the coil permanently. I mean when power is there, when current is allowed. If current cut off, then the coil rotation will stops. We will speak in class again, next period, next session.